All right, you're doing it wrong. I'm going to walk you through some of the specs that you're trying to do so you can make a custom Eagle part. So this is your data sheet that you brought up here. And if we look, the pitch is given center to center here on the screw, and that's 10 millimeters. And then if we look down on the pin here, we have the minimum pin width is 1.1 millimeters, and the maximum is 1.8 millimeters. So we want to make sure that our holes are large enough that we can fit that in. And you usually want to give a little bit of, a little bit of a margin, probably 100 microns or so for these type of things. So if you do a 2 millimeter hole or something like that, that should be just fine. Also note the units down here says millimeters. That's how we know everything on here is in millimeters. Sometimes they'll have millimeters, inches, whatever. All right, so the next thing we want to look at is how long this is. You're looking at 3 post screws. So in this case, we're going to be looking at dimension L, which is kind of your outer length here. If we go down to this side, it says dimension L is N, which is the number of poles, times 10 millimeters. So in this case, yours would be 30 millimeters long. We can actually look at our tolerance here. So because we're between 2 to 6 poles, we have a tolerance of about 150 microns on there. So we probably want to add in a little bit of tolerance for that. Finally, we have the width that we're looking at, and it looks like for all of these, that is 14.6. And you can also look at your pin offsets here, which we will look at more once we go to do the design. So let's show how you can do this in Eagle. If we go to Eagle, go to Libraries, right? We can go and say, let's add a new library here. All right. And we're going to start off with the footprint, because that's what we care about the most. So let's go ahead and add a footprint here. And you can call it whatever you want, just something that makes sense. I'm going to call it 3 post 10 millimeter, something like that. All right, so now that we're in the footprint, we want to actually put down our pad, which is this one here on the left-hand side. There are 2 main specs that we want for this, which is the drill and the diameter. Let's start off by setting our grid size here to millimeters. Set that to 1 millimeter and 100 microns. There we are. And now we want to decide how big these pads should be. So the drill, as we said, if this is 1.8, we want 100 microns on both sides of it. That would be 2 millimeters. So we'll set our drill, which is the hole in the middle, to 2. And then our diameter, we want that to be pretty large. So if we're talking our pitch from here to here is 10 millimeters, that means that a radius of 5 would completely bump up against each other. So let's say maybe a radius of 4. That'll give us 2 millimeter gap between the pads so that you don't bridge them when you're soldering. So that should be plenty for that. And so that comes out, if it's a radius of 4, that's a diameter of 8. And there we go. Let's go ahead and place down that first one. Now, one thing I like to do, if we know the pitch is 10 millimeters, we'll just set the grid pitch to exactly that. And there we are. We've got 3 of these things here. Now, if you just wanted to, make a really quick and dirty pad or something like that, that's basically all you need to do. Hit escape there. However, in the case that you want to use this maybe for future products, maybe you want to make a slightly nicer example. So let's look at adding in a few other things layer-wise so that we can, help out with the layout. So one thing you might want to do is add in a little outline around this here so that you know where to not put other components, right? So to do that, let's go back to a smaller grid size here, and we're going to, so you can choose the layer that you're at. I like tdocu. If you can do tdocu will not show up, or document will not show up on your actual board. So it's just there to help you when you're laying out stuff. If you want to actually put your own alignment marks, then you can put those on other layers, like tplace, for example, is where you would actually put like a little angle bracket if you wanted to have a place to show exactly where to line up the parts. But this should be fine. So now let's go ahead and look at the dimensions that we need from this. So the first one is we're going to have, let's just draw some lines here, right? So we're obviously going to have something like this, and that, right? The box. Now the first question is, how far from origin over to the left side is the line? And that would be determined by this right here. So it shows from the center of the last pin all the way over to the side is 5 millimeters. And if we remember back down here, we also have an additional tolerance of 150 microns on there. So let's give ourselves a little extra space just in case there's variation in manufacturing or something like that. And let's put this one over here at 6 millimeters from there, right? So you could count over and figure that out, or you can go directly into properties and you can actually type it in. So we actually drew it correctly the first time. That's actually 6 millimeters over there. And then as far as where this other side here is, again, you could count over, you could basically eyeball it because you know it's 2 off of the side there, 2 off of the side there, because that's a radius of 4. Or you could say from here, we know it's 10, 20, and an additional 6, so 26. And there it is there. So these are XY coordinates. So the next part we want to know is, where it is in this direction. And we can see that the distance from the pin to this edge is given as 2.35 plus or minus that 0.15, right? So we can round this up. Again, this is just for placement for our own sake. So we could round that up to 3, right? And that just means that, there we go, okay, that's 3 away. So that's really easy there. And of course you can double check that. Just going in there, and it goes to -3, which is 3 below the origin there. So we know that these might stick out a little bit under the side, which you might want to reduce the diameter if that matters to you. Who knows? But then the last dimension we need is the width here, which is 14.6. And so if this is -3 and we're adding 14.6, let's say 15, again, round that up to a slightly wider value. Let's say 15 minus 3, that'd be 12. So we would want this one to go all the way up to 12. And indeed, that's exactly, I drew it almost right in place. Sure enough, right off the bat. Okay, so that right there, very simple layout. And this line just shows where you don't want to put any components because the connector would end up on top of that. So now we'll save that. Maybe let's add a few more things. Okay, but first, so Documents Eagle Libraries is the default in new versions of Eagle. Let's call it that for now. I don't have a library picked out for that. You can always go back in the footprint and edit here. One thing you might want to do is give these things names. So if you have a known, let's see if they have a known pin order on here. And it does not look like they do. So let's just say we're going to call, let's say we're going to call this pin, pin 1. We're going to call this pin, pin 2. And we're going to call this pin, pin 3. There we go. So just as long as you're consistent throughout your use, it shouldn't matter. Sometimes manufacturers will actually say, oh, this is the pin 1 side or something like that. But don't see any such note here. So that should be fine. All right, so we're going to save that. Now we can go back to the table of contents here. And now we got to create a symbol for it. So symbol, again, can be as complicated or as easy as you want. So I'm just going to call this 3-pin. And basically you can use whatever you want for this. I like to pick something very simple and compact for these type of things because often they'll get very large. One thing you never want to do when you're in this mode is go off of the 0.1 grid with your pins. You can go off of it when you're drawing, but if your actual pin connections go off of that, you'll get these nasty errors that are called close but not connected, right? Okay. So I'm just to say we got 3 things there, and that's what we'll connect. And Yeah, that's fine. And you could maybe make it something fancy or something. I don't know. Draw a rectangle around it. Sure, why not? You can draw whatever you want. The key is you want to make sure that the origin is somewhere where you know it is. That's that kind of faint light cross there. One useful thing when you're working in these, if you select everything using the selection tool, then you go to the move. If you control right click, that applies everything you do to a group. So that's a really useful control. All right, and then let's use the name tool again. We're going to name these pins. We're going to call them pin 1, pin 2, and pin 3. All right, and I'm going to pull them up actually so that those pin names show up a little bit. We'll go there, and you know what? Delete that guy and just use a line because I think that's a little bit more than I want. There we go. Something simple like that. Make it as fancy as you want. You can make it match common symbols. Key is just make sure you stay on that 0.1 inch grid line. Otherwise, you will have headaches later. All right, so that's simple. Now let's go back to table of contents, and now you got to actually create the device. So we're going to call this one, we'll call it 3 post 10 millimeter, something like that. And the beauty is you can reuse footprints and symbols and stuff. So once you get a fairly large library, you can continue to reuse them. So the first thing we want to do is add part. We only have one there. Let's go ahead and add that. And that's in this little box here, so we just place it. And again, you can have multiple parts inside of a single device. So that's useful if you want to break out like a multi-part op amp or something like that into individual symbols. All right, and then here, we're going to do add local package and pick that package that we had, and that'll show up in this dialog here. Now you can go on and edit all the other commands, but the main thing is get it wired up, right? So let's go ahead and we're going to do connect, and then you can do your wiring straight across here. So in this case, we're going to say GS1, which is this item here, and then which pad it's connected to. We want 1 to 1, 2 to 2, 3 to 3, connect, and then you're all good to go. Now there's two other things that we want to add in here that may be useful. So if we go back to this symbol, and if we change our layer to names, we can add in text. Now if you do caret name, or I guess greater than name, all right, and then we'll do greater than value. Just to show what it's like, and we'll put that on the values layer. All right. I'll save that. Now if we go back to our device, we can see that value isn't populated yet because there's no value for this item, but that name is $1. That's why you saw that in the connect dialog. So if you have multiple instances, they'll show up there, and when you actually place it on a schematic, that's where it will get the name. If you want to use the value, you can hit value on, and then that'll force it to have a value. But in this case, because there's no appropriate value, it's not like a resistor or capacitor or something, we're going to keep value off in that case. All right, and we go prefix, and this will be whatever you want your prefix for the name to be when you actually place it on a schematic. So for resistors, you would do R, for capacitors, C. For a connector like this, you can use whatever. J is a common one. All right, we'll save that. Finally, before we use the device, we may want that J1 thing to actually show up. So if we go in here, select the layer T name, there we go. We can actually place it down. We'll go name like that. So it'll use the automatically generated name, and we'll place it something like that. Save. All right. Okay. So now let's go ahead and we're going to create a new project here. Okay. In this project now, we're going to create a new schematic. So the first thing you want to do with the project is double click it. That makes it active. And an active project will keep track of which libraries are loaded and whatnot. So you always want to make sure you're working within an active project. So we're going to create a new schematic. Over here on the left-hand side, you're going to hit Add Part. Now this is where you might go in here and search and say, oh, it's not showing up. What's going on with that, right? Well, if you go Open Library Manager, it'll do library updates and all that. Yay. We go to Available, and we need to browse and actually add that library for the first time. So I'm going to click this library here. Okay. So that adds it to the available list. Now if I scroll down to the available list here, or you can type it in there, you get Reddit, hit Use, and now that one will end up in the In Use column here. So now, once that's done, if we go in here, we should be able to find it right there. One other thing for the searching on here. So let's say we wanted to search for this part. If you search, let's say we search 3 posts, something like that, right? So I'm going to get out of there, say 3 post, hit enter, nothing shows up. The reason is you have to make sure you use wildcards. So we do 3 post star, that'll find anything that starts with 3 post. I got in the habit of just using star, whatever I'm searching for star, in case it's a prefix. So that makes it really easy to help pull it up. So there it is, hit OK. And now we can place it on a schematic just like any normal thing. The value is by default set to the component name, and you can change that using the value command, or you can just delete it if you don't care for it. And then that's the actual part name that would show up there. All right. So then, once you have this part in here, you wire it up, you do whatever, you can just go, generate the board, create from schematic, and there you are. We've got the item here. Click there, and place it wherever we want. Maybe reposition the label around wherever we want. Change the size of it, maybe something like that. Might make more sense. And there it is. So that's kind of a tutorial walking through creating the part, putting it in, everything like that. Hope that helped. And so yeah, good luck on your project and have a nice day.